Hello guys, I'm Chris. Today I'm gonna cover the TensorFlow tutorials, and I'm gonna start with the tf.data. So tf.data is a module for the TensorFlow developers to read and write the dataset. So in the machine learning project, actually 75% of the project time is consumed by the data preprocessing. So the tutorial is quite simple, and the best material for the TensorFlow is TensorFlow official tutorial. So I'm gonna use the Colab to introduce the details of the code step by step. So if you click this run in Google Colab here, you can see the tutorials here. Okay. So our first tutorial will cover the CSV data routing. So we have the CSV file over here, and you are going to read this data into the tf.data format, tf.data.dataset. And this CSV file will store the Titanic dataset. So this dataset have a feature that passengers data and the label will be survive. This passenger survived or not. So the features like age, gender, ticket class, and their data is in the feature. So let me explain this part. So try. In Colab, you have to define which version you will use in this tutorial. So we'll specify we are going to use the 2.x. So we are going to use 2.0, and the log says TensorFlow 2.x is selected. And this part is feature. This part of the import is for the Python 2 and 3 compatibility. And functools and NumPy, you are going to import the NumPy and TensorFlow. And TensorFlow data URL. So here is the web URL of the CSV file. If you just click the CSV file, you can see the data set like this. So this is the label of the data, and these are the features. So this is the raw data. So we have to, before we use this data into the machine learning, you have to preprocess the data. So tf.keras.utils get file will load the file from the web URL. Let's do this. So this module will download the file and store it into the train.csv file. Yeah. Next, mp.set print options. So this precision is for the like in a float value. If there is a 1.12345, if we set this option, then we will only see the 1.123 like this, precision 3. So this code will just print the top of the data, like 1, 2, 3, 4, 5, 1, 2, 3, 4. So these are 10 rows, the first 10 rows of the data. Actually, this Linux command. So if you are using Windows, this command will not work, I think. And as I mentioned earlier, survived is our label data set. So survived or not. So this function is get data set. So we already downloaded the data and stored it into the train.csv, and here is our train data pass, and we'll pass this parameter into the get data set. And tf.data experimental make CSV data set will load the data in batch size 5. So every step, the training process will get 5 batches from the data set, like 5 rows each step. And label name is label column. We just specify over here. And any value means null value and num epochs. So we are going to only do the one epoch training. Yeah. So these are training data and load test data. And this show batch will just take one data set, batch level, and each batch have a key value. So let's see how we work. So we input this raw train data over the show batch. It will show 5 data set, 5 batches in the data set. This is the first row, second row, third row, first row, and fifth row. So we have sex, age, sibling spouse, and parts, fair, class, tag, and Barkton, alone. So yeah, we're gonna start the preprocessing step. Yeah. So the whole columns over here, you can specify the survived, sex, age, sibling, spouse, but so if we just specify just small number of columns, that it will load that exact columns only, like this. So in this batch, we didn't use like parts, fair, and Barkton. So yeah. Survive. The data type of survive is 1 or 0, and age is a numerical data. And sibling spouse has also a numerical data. And parts, let's see, parts is 0, 0, 0, 0. Yes, yeah, it's a numerical data. And fair is also numerical data. Yeah, here. Since the data set is iterable object, so you can use iteration function here, and we can get next iteration from the data set. And this function packs the data together all columns. And once we pack the data here and take one data over here, we can get features and labels. Like here we have each feature have each vector over here, but we pack the features and label, then we can just pack this data set into just 25.04.21.075 like that. And show patch. So so the preprocessing step of the numerical data and the categorical data is different. And usually we you can directly use the numerical data into a feature vector, but in this step, we're going to normalize the data. So here's the numerical features, and here's the raw data, and we'll map the raw data into packed numerical features. So here's the original data over here, and the packed data are like this. So packed train data, and what is data normalization? We usually normalize the data set like we have 0 to 100 scale data. We just divide this data by 100 so that the data distribution will be like 0 to 1. That's the most common scaling preprocessing. And also we can also get the mean and the standard deviation of the age, sibling, part, and pair. If we know the mean and standard deviation, we can just divide minus data minus mean and divided by standard deviation. That the distribution of the data will be like a normal distribution, standard normal distribution. So yeah, the data will be like different from the raw data. The reason why we just normalize the data is for the training efficiency. Yeah. So so these are the original data set from the raw data, but after the normalization, we got this kind of data. And the important part of the preprocessing is categorical data. The categorical data is like male or female, first class, second class, third class. And usually the categorical data uses string data type in our raw data set. So all of these are string data, first, second, third, A, B, C, D, E, F, G, and Turberg, Sosson, and Odom Y, and so here is our categories, and we're going to preprocess it. So here are the categorical items. And by using tf.featureColumn.categorical column with vocabulary list, if we just input the vocabulary list array into this function, it will return categorical column variable. And categorical column, we're going to append all the categorical columns over this categorical underbar columns variable array. So we have the numerical columns and categorical columns all together. Yeah. So as you can see here, in an example batch, we have lots of subcategories like male or females. All of these categories are encoded one-hot encoding, and all the one-hot encodings are concatenated into like these vectors. Yeah. So combined preprocessing layer. So we have numerical data and categorical data here, categorical columns and numerical columns. And let's see how our data set will look like after preprocessing. Yeah, 1 0 0 0 1 0 0 0 0 0 0 0 0 0 1. And these are numerical data. Yeah, preprocessed numerical data. So we're going to use the tf.data sequential model. First, we will use the preprocessing layer over here. Yeah. And after preprocessing, there are 3 steps. First, dense layer consists of 128 cells, and another 128 cells, and activation function is a value function. And the last step is 1 dense layer. And the activation will be sigmoid. So the loss function is binary cross entropy, and optimizers are Adam, and metrics are accuracy. So Adam is the most common optimizer when you start the machine learning and deep learning project. And the final value over here are like 1 single digit. And using this digit, you can classify the passenger will be survived or not. So let's train the data set. So this shuffle function will shuffle data, and test data, here is our test data, and model.fit will just train the machine learning model. Yeah, the training is finished. And model.evaluate will evaluate the performance of the model. So the performance accuracy of the test data set is 83%, and the loss is 0.45. Also, we can predict the test data set using this predict function. Yeah. So our first tutorial is done. It's a simple tutorial that can load the CSV data and preprocess the numerical data into the numerical feature after normalizing it. And for the categorical data, you can use a TF categorical feature like here. Using this function, tf.featureColumn.categorical column with vocabulary list, it will simply transform the vocabulary list into the one-hot encoding, and is quite easy to use. And by just concatenating the categorical columns and numerical columns, we can easily define the preprocessing layer. Yeah. So the tutorials are done. So most of the tutorials for machine learning, they cover the modeling part, but in my opinion, data preprocessing is quite important for the real machine learning project. So I'm gonna cover details about the data preprocessing, not only the CSV, TF record, and big queries like that. Yeah. So thank you for listening my tutorial. See you next time. And please follow my channel, YouTube channel, and please click the like button so that you can subscribe more tutorials like this. Thank you.